we're trying to match the equation with the graph. First, we're given this equation. Let's write down the component. So what do we have here? So we have x is equal to u cosine of v, y is equal to u sine of v, and then we have z is equal to v. Let's think about u. Okay, let's fix u first. So I'm going to color code this, and let's this u over here to be in this orange color here. So the first case, we're going to think about u is constant. So keep the u constant and look at the graph curve. So if u is constant, then what happens? Then we're going to have this to be x is a constant times cosine v, y is a constant times sine v, and z is equal to v. As we talked about before, right? Remember for the helix? So when we have helix, when we take the parameter t, then the x component is cosine t, y component is sine t, and the z component is t. So this is very similar to this. So it's a constant times cosine of v, constant times sine of v, and then the z component is v. So you have this v as a kind of like this parameter t in this case. So it is a helix because you can see that this one here, if you have x squared plus y squared, should be equal to u squared. So you're going to have a circle when you project the curve on the xy plane. It's going to be a circle. And then the z here is as v increase, and the z is going to go up. So when you have a circular motion together with the upward motion, then you get a spiral. So this is a helix. So we know that it should be a helix. So looking at this, it looks like it has a helix. This one here has a helix. But let's also look at the grip curve for the other one. Next, we're going to make this v here to be constant. So this time we're going to take this v to be constant. Let's see what happens. So when v is constant, now let's think about this. From the first one over here, let's try to isolate cosine of v. So cosine v is x over u. And then from the second one, sine of v is y over u. So, and then we know that sine over cosine is tangent. So we're going to actually, an easy way to do this is actually we're going to take this equation and then divide by this equation. Maybe that's more direct. So I like it that way. So I'm going to take this is the first and this is the second. I'm going to take the second equation, divide by the first equation. And what I come up with is y over x is equal to sine of v, because the u divide out. So sine of v divided by cosine of v, which is equal to tangent of v. And remember, we keep the v here constant. So this one here is just a constant. Tangent v is constant. So you see the equation for that is y equal to a constant. Let's call the constant k. So that's equal to kx. So that, what does it mean? That means the projection of the curve on the xy plane is going to be a line that passing the origin. So if you have any horizontal plane, z equal to constant, its intersection with the surface forms a grid curve. So imagine you have v to be constant. You have a plane over here, a horizontal plane, when you have z equal to v. So the grid curve is going to be passing these points on this z-axis, and it's going to be like that. As you increase v and move the horizontal plane upward, then the intersections will be gripped curved like this. Think about those grip curves kind of like the steps of a spiral staircase. that grip curve is going to be a straight line that passing the point on this z-axis there. And it go like that. Because you know that on the xy plane, y equal to kx could be going this way, anyway. They all passing the origin. It go different way. It's a z increase. It go like that. So those are, grip curve. When you keep the v here constant. So the choice for this is this one, for number 4. This surface is a spiraling ramp, so it should be like this. Yeah, but it seems like it's easier if you know the answer there, and then you try to walk backward, right? But we actually deduce that. So first I keep u constant. I deduce that the parametric equation will be like a helix, okay? And then we keep the v constant. We got the equation in x and y will be y equal to kx. So the projection of those grip curve on the xy plane will be straight line that passing this origin. So that's why it look like this.